Welcome to Under the Microscope. This series is brought to you by the Real Scientists Nano team. Our goal is to provide a platform where scientists can communicate their work and interact with the public. With that in mind, every week we introduce you to a scientist working in the field of materials and nanoscience. Hello everyone. Today we have with us James Armstrong, who is a research fellow at Imperial College London. Hi James, how are you doing?
Hi, I'm very good, thank you.
Wonderful, wonderful. Um, let's start by understanding your scientific journey so far, your scientific career, so to say. So, how did you end up in your current research field?
It was completely by accident. I trained as a chemist, quite an inorganic chemist, and then I took on a PhD, again, slightly by accident. I ended up on a doctoral training centre PhD at the Bristol Centre for Functional Nanomaterials,
Right.
which is a wonderful PhD program. In this program, I ended up doing a not particularly physics-based PhD. I ended up moving towards working with cartilage and cartilage tissue engineering, but I still had this exposure to nanoscience and working with a lot of physicists and engineers. And then this allowed me to learn about some really interesting techniques, such as the optical and acoustic trapping and the magnetic nanoparticle work, which people were applying in the engineering world, but which I've now taken and I've applied to my current interest in cartilage tissue engineering. I moved away from Bristol. I took some of these ideas with me. I wrote a few fellowships, and I'm now working on these actively at Imperial. And I think this shows the importance of being flexible when it comes to your science, changing direction, and then also the importance of interdisciplinary science. I had the exposure to those physics and engineering techniques, but I also had the exposure to the biological questions, and this has allowed me to sit in quite an interesting space.
Yeah, it's like you're getting the best of both worlds, it seems.
Yeah, it's challenging because you have to talk many different languages, and it means you're not always a complete expert in either of the fields. But if you can talk those languages and you can bring the best ideas, I think there is some really interesting work that can be done.
Yeah, absolutely. So where would you say your current research fit in this big picture of materials and nanoscience? You did mention a little bit about it in the short podcast, but could you elaborate a bit more on that? And in the big puzzle of materials and nanoscience, where does your current research field fit?
Sure. So a lot of the work I do is quite biological. It's quite large scale tissue constructs, but I employ a lot of nanoscience-based tools to get there. So I have my training in nanoscience. I've been adapting these tools such as optical trapping, acoustic trapping, magnetic nanoparticles, and I've been using them to organize the structures of tissues in quite an unusual sense. I always have that. I always have that input from nanoscience into my research, and then use of materials is quite pragmatic. I typically form these patterned arrays of cells and growth factors, and then I use materials such as hydrogels to encapsulate and immobilize those arrays, which allows me to then take those forward and carry out a tissue engineering process. So materials are one of the key tenets of tissue engineering: cells, materials, and chemicals. So getting the materials which support the cells during that process, but which also are compatible with some of the nanoscience tools I'm applying, that's the major challenge of what I'm doing day to day.
Okay. It sounds like you do a lot of interesting experiments and are involved in a lot of interesting research projects. So if you have to pick one that you're most proud of, or the most quirky or the fun one, which could be challenging because most of your projects must be close to your heart. But if you have to pick one that you're most proud of, could you do that and explain it to us in simple words in the section we call In Other Words?
Sure. So, I mean, you're right. I'm passionate about all of the research projects that I do. I only do work which is I find interesting, and I find fun, and which I find useful. But I think the project which I'm most proud of was a very recent piece of work, which was published this year in Advanced Materials by my student Valeria.
Mm-hmm.
And this was a very long-standing project. We came up with this idea 4 or 5 years ago, and we thought, could we use sound waves to activate enzymes and also as a way of assembling hydrogels? And she worked incredibly hard on this project, and there was lots of ups and downs and changes in direction, but we got this working. And the reason this excites me is it has great academic novelty. Nobody had ever done this in this particular way before, and the ability to activate enzymes and trigger hydrogel formation has a lot of real clinical or industrial potential. So ultrasound has a fairly unique set of properties compared to the use of temperature or light. It can be used to stimulate processes very remotely and very in a very different manner to those other triggers. So it opens up opportunities in triggering gelation in closed containers or sealed opaque pipes, or also potentially doing some of these processes in vivo in deep tissue.
Okay. That's interesting. Yeah, I can understand why you picked this as the research project that you're most proud of. It does sound interesting. And I hope you can go into the details while you're curating the Twitter account.
Sure, thank you.
Awesome. Let's move a bit away from the research from the lab and go towards the other responsibilities usually the researchers have, which is teaching. So do you teach? And if you do, would you like to mention the courses that you teach?
Sure, I do a little bit of teaching. I contribute to the Advanced Tissue Engineering module, which is a course for bioengineers at Imperial College.
Right.
It's a great course to teach in. It's a lot of very interesting material, a lot of very invested students. It's a part of my work which I really enjoy, and it's something that I'd like to do a lot more of in the future.
Okay, teaching. That's good to know. Awesome. Let's move back to your research experience now, and I hope your experience so far has been wonderful and will continue to be wonderful. Having said that, if you have 3 wishes to improve your research experience, what would you ask for? And I'm not promising anything here.
Well, I think by far the most important thing in everybody's research experience is to have an improved awareness of mental health. The well-being in science is something which I think we're really struggling with. I've seen so many issues arising, and there isn't always the support mechanisms there, and there isn't always the knowledge of who to turn to when you may be encountering a well-being issue. So I think this is something which has been neglected in science, and it's something which really seriously needs to get better as we move forward. And then second point is kind of similar. I think there's an improvement of diversity, I think is essential for modern day science, and we're getting there. But there's a lot of work to be done to improve the diversity of genders and the diversity of different ethnic groups in science, all the way up the academic ladder. So not just at the student level, but also as you move towards the more experienced staff members. And then a third point is a bugbear of mine. So it's people trying to not get too hung up on the question of why is this useful? So it's an important question to ask. And it's a completely valid question to ask of funded science. But it should never be an impediment to do basic science, because basic research is important and it can add to knowledge and lead to discoveries further along the line. So I think it's a question should be asked, but it should only be asked in moderation.
Yeah, that makes sense. All three of your wishes are extremely important, and I definitely agree with you on all of them. And I would like to believe that we are working towards it. More mental health awareness in academia, diversity, or rather inclusion. I would also add inclusion to the list.
It's
Um,
it's improving. It's definitely improving. We're getting there, but there's a lot more we can do as scientists to improve the situation.
Yeah, absolutely. And I hope we are working towards it. It happens in near future. I hope so. We progress towards it at a faster pace. Um, Speaking of future, what are you most looking forward to in the next 3 months?
So I guess we're in a bit of unusual times at the moment. So I am really looking forward to the labs reopening. I've enjoyed spending time at home, spending time with family, not having to commute every day. But when the lockdown happened, I was just about to finish a really exciting collaboration, which I got going with the Sanger Institute. So we're carrying out a very interesting sequencing project, and we were just about to send off our final samples when lockdown happened. So now these samples are in the freezer. I'm praying that there's no freezer breakdown or electrical faults happening while I'm away.
Right.
And I'm just really excited to get back in the lab to send those samples off to Sanger, finish off that project. But of course, I'm aware that this can only happen once the whole situation is under control. So that's it's a bit up in the air, but that's my hope for the next 3 months.
Okay. Yeah, I hope so too. I hope the entire world comes out of the, like, we are safe to come out of our houses and go to the labs and go around our normal business, the normal that we started the year with.
Yeah,
Well,
not the new normal.
not the new normal, absolutely. Yeah. Before we let you go, James, what we want to understand from you is what are the scientists, particularly in your field, working towards? So, what are the big questions that are faced by today's scientists, specifically in your field, of course?
Well, I think the field is thriving in acoustics, and I mentioned some of the challenges in 3D manipulation of acoustics, and then more
Right.
broadly the challenges of um, generating natural structures in tissue engineering.
Right.
So I think those are the specific challenges in acoustics and tissue engineering that I'm trying to address, and I think the field needs to be focusing on.
Right.
But again, I think there's these broader issues surrounding the environment with which we carry out our science, the mental health and well-being, and inclusivity and diversity, which I think they need to be top priority, because for me, no scientific advance is worth compromising the well-being of scientists, and that has to be top priority for me.
Yeah, that makes sense. Absolutely. So it has been wonderful. I learned a lot about a completely new field, which is absolutely new for me. So thank you very much for that. And thank you for speaking with us. And we are looking forward to having you on Real Scientist Nano.
Thank you for inviting me. It's been a pleasure.
Thank you for listening. To know more about us, please visit our website realscientistsnano.org and follow us on Twitter at realsci_nano.